Welcome to aminacademy.com. In complex analysis regarding elementary complex functions, let us do some solving problem. Prove that the zeros of sine z and cos z are all real and find them. Here, first one, sine z equal e power iz minus e power minus iz over 2i, which is equal to 0, because we have to find the zeros of sine z. Then from this, by cross multiplying, we can get e power iz minus e power minus iz equal to 0. 0 into 2i is 0. From this, we can get it e power iz equal e power minus iz. Then further, e power iz minus 1 over equal 1 over e power iz, which gives, by cross multiplying, e power 2iz equal to 1. E power 2iz equal to 1. So from this, e power 2iz equal to, instead of 1 you can write e power 2k by I, where k equal to plus or minus 0 plus or minus 1 plus or minus 2, like it. Therefore, hence we can say if base is common, therefore 2iz equal 2k by I. Then from this, 2 to cut, and we can say z equal k pi. I cut z equal to k pi equal the zeros of, that is, can say z equal to 0 plus or minus pi plus or minus 2 pi plus or minus 3 pi, like, or zeros. Therefore, zeros of sine z is this. Therefore, z equal to k pi is the zeros of sine z. Now, next, same for cos z. Cos z can be written as e power iz plus e power minus iz over 2 equal 0. From this, we can say e power iz plus 1 over e power iz equal to 2 into 0 is 0. From this, e power 2iz equal 0. E power 2iz equal, not, it's equal to minus 1, because by taking LCM e power iz and cross multiply, which is equal minus 1. E power 2iz equal to minus 1, which is the minus 1 is equal e power for negative number 2k plus 1 pi I, where k equal 0 plus or minus 1 plus or minus 2 like it goes. Hence, two k plus 1 by I and 2k by I and z equal to k plus half pi. Therefore, z equal, that is zeros of cos z. Z equal to here plus or minus pi by 2 plus or minus 3 pi by 2 plus or minus 5 pi by 2 is the value of z. These are the zeros of cos z. Hence, this result. Next question. Prove that 1 minus tan h square z equal sec h square. By definition, we know that cos hyperbolic z equal e power z plus e power minus z over 2, and sine hyperbolic z equal e power z minus e power minus z by 2. From this we can write here cos h square z minus sine h square z, which is equal, that is cos h square z e power z plus e power minus z by 2, the square, minus, or the sine is e power z minus e power minus z by 2, the whole square, which is equal, expanding whole square, that is here it comes e power 2z plus 2 e power minus 2z by 4 minus e power 2z minus 2 plus e power minus 2z by 4. Here, look at this. All e power, by taking LCM is 4, e power 2z minus e power 2z cut, 2 minus of minus 2 is 4, and e power minus 2z minus e power minus 2z is cut. So 4 by 4 is equal to 1. We got the result e cos hz square minus sine h square z is 1. Now we rewrite that one. Cos h square z minus sine h square z equal to 1. Divide throughout by cos h square z by cos h square z divided by cos h square z. So 1, because cos h square z over cos h square z is 1. Sine h square z over cos h square z is tan h square z equal 1 over cos h square z is secant h square z. So hence we prove. Hence proof. here. Prove that sine x iy equals sine x into cos hy plus I cos x into sine hy. Yeah. Next question, we have to sign for this. We have to first find sine iz. Sine iz equal e power I into iz minus e power I into minus I into iz over 2I here, which is equal e power I squared is minus 1 minus z minus e power I squared is minus 1 over minus is there plus by 2I. Then it is equal, take out I. That means you have to multiply up and down I, that is equal e power minus z minus e power z over by here I squared is multiplied by squared is minus 2, that is it's inverted and gives 2, which is equal I of sine hz. We proved sine iz equal to I sine of hz. Then same for cos iz equal e power I of iz e power I of iz plus e power minus I of iz over 2I over 2, not 2I, because it's cos 2 equal e power I into I is minus 1, I squared is minus 1, so it is e power minus z minus e power z over 2, which is further which is equal cos hz, that is cos iz is equal to cos hz. Now using these two results, that is sine iz equal I sine hz, cos iz equal cos hz. Then now we'll write the given formula sine of x plus iy equal sine x into cos iy plus cos x into sine iy. Now here this is a basic expansion, that is sine a plus b equals sine a cos b plus cos a sine b. From this we put the result sine x cos hx. Here sine x is sine x and cos iy Sin x into cos hy. Here cos iy comes. Cos iy is cos iy is I sin x plus I cos y. Sin x plus cos iy plus cos x sin iy equal sin x into cos h cos h y plus cos x equal I cos x into sin hy. I cos x into sin hy. This I, that is here, which is equal sin z equals I sin hz, that used here. So hence proof. We have done. Please subscribe our YouTube channel.